So can I use that to figure out what these guys are?
Yes.
How can I use that?
Subtract.
Well, take away that 7, that's what? 5, and then I can divide it by 2 because they should be the same, right? Because they're on both sides of 0. So what would we get for those? 2.5, 2.5. So now I can answer the question. What is the integral from 0 to 6? 2.5 plus 7, which is 9.5. Cool? What if I said the integral from -3 to 6? 12, right? Cool? What if I said from -6 to 6? 19? Yeah. Good? Does the little number line trick help you there? A little bit, right? Especially for those kind of problems. Couple more examples to look at. 5. And we'll be done for the notes for today. This will be on the quiz here. Tomorrow. Okay. I mean, we can take it when we come back, but I don't know how good of an idea that is. What do you think? Yeah, we'll get together during the break at McDonald's. We'll have the quiz there.
I'm down.
Down?
No, I said, what's the quiz on?
What's the quiz on? Everything that we've been learning regarding integrals. And anything is fair game. I might throw in some derivative questions as well from the past. Some limits, let's throw in some limits. I'm not going that far back yet. Alright, so now let's look at this one, okay? It says picture to the right is the graph of f of x. What can you tell me about that graph? Is it even or is it odd? It looks like Darth Vader. His helmet. What is it? It's an even function, right? So what's on the right is the same as what's on the left. Perfect. It's symmetric with respect to the y-axis. So we know that this guy is even. Alright, the first question says, what is the value of the integral from 0 to 3 of that exact function that's there? So what could I do to figure out this value? Since I'm not given a function. We can calculate it, okay? How? That's what I want to know. So calculate the bounded space, right? From 0 to 3? Yeah? So let's maybe go from 0 to 2, because we said it wouldn't be what right here? Wouldn't be differentiable, right? So we're going to calculate that space. And if I look at it, it kind of looks like how much of a circle? 1/4 of it, right? And then this space down here looks like a what? Could be a rectangle and a triangle, or it could just be a what? A trapezoid, right? Whatever works for you, I don't care, as long as you calculate the bounded space. Okay, so this is how much of a circle you said? 1/4, okay, so how do I find the area of a circle? Pi r squared, so we're gonna end up with 1/4 times pi. What's r in this problem? 2, right, that would be the radius. Okay. Plus, what's the area of this trapezoid? 1/2. What's the height? 1. And what's the base 1 plus base 2? 2 plus 3. Parallel sides, right? So we end up with pi, right, because the 4's cancel out. Pi plus 5/2, right? We're adding 2 and 3, not multiplying them. 2 plus 3 is 5 times 1 is 5/2. Good?
Yeah.
Whenever they provide you with the graph of the function that you're integrating, you know that you need to find the bounded space in order to calculate that integral. Okay? Don't forget that. If they don't provide you with the graph of what you're integrating, then you need to approach it differently, right? We'll talk about that in a little bit. We did a little bit of that yesterday. How about from 0 to 4? We already did from 0 to 3. Now we need to just add this little piece, right? What do I know about that little piece?
It's the same as.
Same as this one up here, right? Okay, so then they cancel each other out.
Yeah.
Okay, so we only need that part.
Yes.
So what was the area of this piece up here?
Fine.
Pi, and what would be the area of this rectangle?
2.
2, so this would end up being just what?
Pi plus 2.
Pi plus 2. Do we understand or no? Yes? How about if I go from -3 to +3?
0.
0?
No, it's 2 times.
0? So you're saying they cancel each out from here to here?
Oh, yeah.
No, they what? They double, right? Okay, so it's actually equal to 2 times the integral from 0 to 3, right? Which we figured out in number 1. What was the answer to that in number 1? Pi plus 5 over 2 times 2, right? So we calculated that already, just multiply it by 2. So we end up with 2 pi plus 5. Very good. Okay?
Value.
Alright, be careful, okay? So let's look at these bottom two. These are going to be a little bit more tricky, okay? So it says if capital F of 0 is equal to 5, what is the value of capital F of 3? Where F is the antiderivative of little f of x. Okay? So we're talking about the antiderivative and they're using f of 0 and f of 3. Yeah? We know that when we integrate a function, right, from a to b, the fundamental theorem says that I'm going to get the antiderivative and I'm going to plug what into it?
B
The b, and I'm going to subtract the antiderivative after I plug in a. So notice that I'm getting that capital F of b and that capital F of a, right? So I can pick out these a and b of the integral by knowing what? The x values in my problem, right? So when you're working these problems out where they're describing the antiderivative to you, you need to pay attention to those x values, okay? So look at the x values to set up your integral. Okay? So I'm looking at an integral from where to where? From 0 to 3, it's always the smaller one to the bigger one. Of what? Of capital F of x or of little lowercase f of x? Lowercase? So what if this was lowercase f of x? What would this one have to be? What if this were lowercase f of x? What would I have to put here? F what? F prime of x, right? Okay? Yes?
Yeah.
If this were f prime, then what would this have to be? F double prime. Do we understand? Yes? Alright, so I know that when I get the antiderivative of this guy, it better be this capital F, because they told me that, right? And I know that that's going to equal capital F of 3 minus capital F of 0. So do you see how I'm getting a problem, an equation set up where I'm using what they're giving me? Okay? Do I know the value of f of 0? So that's minus 5. I don't know f of 3. I don't want to put a number for it, because that's what I'm trying to solve for. That's like my x, that's like my variable.
Do you know the integral?
Do I know what this is equal to?
Yes.
Yeah, we did it earlier, right? On the first example? From the graph? What was that equal to? Pi plus 5 over 2, so we can plug that in. And now we have an equation that we can solve for to figure out what f of 3 would be equal to. Pretty cool? add the 5, so that means that f of 3 is actually equal to what? I plus
15.
15 over 2, could we have also put 7.5? Yeah, could have thought of this as a decimal, 2.5 plus 5, 7.5. Beautiful? See if you could try the next one. What are they talking about there? We gotta think of an integral that we could set up that's gonna throw out the antiderivative, right? Okay, so it has to be an integral from where to where? -2 to 2, right? You pay attention to the x's. Small to big. Of what function? The lowercase f of x, right? Because that's what we're integrating in order to get capital F of x. What's that gonna give us? Capital F of 2 minus capital F of -2. We know this guy because it was given to us. So it's minus -2, capital F of 2. That becomes plus, right? Can we figure this side out? What's the integral of this function that I have graphed here from -2 to 2? So here we're only going from right there to right there. Did we do that already?
Yeah.
I thought we did it.
Yeah, we did.
We did from here to here, but we ended up saying that these what? Canceled out, so technically we did that one, right?
Yeah.
So from 0 to 4 is the same as from 0 to 2, right?
5 plus 2.
What was it from 0 to 4?
5
5 plus 2, but I have how many of those?
2.
2 of them, right? So that's gonna be equal to 2 times pi plus 2, which is 2 pi plus 4, right? And then we're gonna minus 2. So my final answer for that value is gonna be 2 pi plus 2. Beautiful? Papitas? Okay, so again, if this is lowercase f, then I'm finding the antiderivative of f what? Right? F of x is the antiderivative of f prime. F prime of x is the antiderivative of f double prime of x, right? Capital F of x is the antiderivative of little f of x, right? Because we don't know what this represents, right? So I have to give some notation to its antiderivative. Good? All right. Any questions? We good with the properties? Are they pretty easy to work with? Yeah? All right, so for homework, you're going to have 12 problems and then also 2 free response questions to look at.
Are you non-copy?
You what?
Sure.
Are you getting there?
Choose to.
Are you getting there?
I think today. I'm gonna hit him with the
Just like, use the copy.
You get it?
I think so.
You getting that?
Can you use copy?
Yeah, you shouldn't need the calculator. And then the free response questions are non-calculated.
Yes, they
Sure.
go wide open. Wait, do you need the calculator?
No.